Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back. So once we have already completed actuators, now you are ready to run your mechanical system. Your robot arm can now move, so it should not move blindly. So yes, you now know, now that you have also seen the type of control systems which were there to do at least position control. So you see, you require to have a joint angle sensors at times, okay, so that you can give a proper feedback. Why is that required? Because once you reach to a place, you have to stop there, right? Either in a limited case, like you just have to reach there and stop, or maybe you have to go in a trajectory that you saw in the application also. So yes, now that things are moving, no, you have to have some sort of senses, not just to move, not just to have a constrained motion or some sort of control in motion. You also should have many other parameters which are to be continuously monitored at times. Let us say you don't want your robot to get overheated, then your temperature sensor is required, right? So for various reasons you need sensors. So without sensors even humans are incomplete, so with the robot also. So yes, now at least you understand you need sensors. So let us begin with the module called sensors here. That is the third module of this course. So yes, so in this module we'll be covering sensors and transducers. There is some difference between them, we'll discuss about that. Contact and different types of non-contact sensors. Position sensors, very specific to industrial robots. Absolute and incremental optical sensors. Those are very popular in robotics. We'll discuss about potentiometer sensors, magnetic sensors, and Hall effect sensor, which was very much required even in BLDC motor that we have covered already. Velocity sensors, that is tachometer, accelerometer. Accelerometers mostly of MEMS type, we'll discuss in detail. Okay, we'll also discuss proximity sensor, inductive, capacitive, and Hall effect sensors. Force sensor, you have to have some feedback of the forces and torques also, you have seen already. So yes, force sensor, specific kind of force sensor, that is strain gauge based sensors we'll discuss, and characteristics of sensor, that will characterize a type of sensor. If it is in our hand, we have to see different properties which it can give us. Okay, so that is what is mentioned in the technical data sheet also. So all these will be covered in this module. So yes, the demonstration video altogether will be covered as a resource video for this, that I will be sharing with you all at the end of this module. Okay, so let us start with sensors. First of all, I'll introduce you to sensor and transducer in this lecture, and specifically I'll cover a position sensor, optical sensor to be more particular, of two kinds at least, that is incremental and absolute optical sensors, that is to sense the position. As such, sensor is a device or a module. It comes as a module, not just a device. It may be a machine, it can be a subsystem whose sole purpose is to detect events or changes in its environment. If it is environment, let's say temperature, I have to monitor how it is varying over time. Sometimes event, let us say something is every time it is coming and going back, coming and going back. I have to count how many times it has come and it has gone back. So that is the event, number of events I want to count. These are just a few examples, there are many. So yes, what are a transducer in that case? If this is a sensor, so what are a transducer? It can change one form of energy to some other form. Let us say I am sensing pressure, okay? So but pressure actually cannot be fed back to a computer sometimes. So in that case you have to convert temperature to other form, that is electrical energy form, so that it can be taken up by the computer system. Okay, it picks up the signal generated by the sensing element. So now you have something which is a sensing element, you have a converter which converts from one form to other, and then you may have some communication device which can transmit it to a long distance. So you have a sensing element, you have a transducer, you have a communication unit. So all together as a pack will now refer to as a sensor. Okay, so sensor as such, from now and on, if I say sensor, sensor means it includes everything. It includes the sensing device, it includes the energy conversion device as well as the communication device. So it picks up the signal generated by the sensing element. It amplifies, sometimes it amplifies if the signal is very weak. So you cannot have that value directly to the, even in electrical form it is not acceptable to many of the devices. So you may require to scale it up, transmit it, then appropriately scale it back and use it. Okay, sometimes things are not linear, you have to linearize the thing. Your, let us say, barometric pressure varies with height, something. So as you go down into the go down from certain level from the ionosphere, so as you come down your pressure goes like this. Okay, so that is non-linear. Okay, so it is very difficult to interpret when it comes to your system. So maybe your sensors would give you something like this, straight line fashion. So as you are going down, okay, down from higher level to the lower level near to the earth, the pressure is increasing. Okay, so this is going down, down, down. It is the negative scale, to say negative times of h, and then this is your pressure. So you have converted your signal which was initially like this, now it is like so. So that is something which is known as linearization. Okay, and then it can convert from one form to other. Sensors now integrates a device which may be useful to transmit data to a long distance. Sometimes they convert the data to acceptable form which is taken up by the, which can be easily taken up by the processor. Okay, so what kind of data that your processor can normally take is digital signal, normally in the form of RS-232, 485, I2C, Ethernet. These are some of the kinds which were there in your microcontrollers. There are industrial communication system also are there. Now you have already, you are aware with Profinet, Ethercat, Profibus, right, various kinds of industrial communication systems also. Let us move ahead. So what are different types of sensors that is there in the industry? One of the very common one that you know is, now at least you have to have joint angle feedback. So angle feedback, okay, your joint is moving, you want to know where I am, okay, so that is to be sensed. So at least position or the displacement sensor is required. There are various types of those sensors. It can be a potentiometer sensor, it can be strain gauge sensor, capacitive sensor, right, differential LVDT transformers are there, optical encoders are there, gray code. We'll see a few of these in this module also. Okay, so that is position sensor, proximity, eddy current, inductive, capacitive. At least these two will be covering in this module. Nozzle flapper, that is a pneumatic type of sensor. Hall effect sensor, will be covering this also. Okay, so velocity sensor, tacho generator, velocity sensor is there in your speedometer also of your vehicle, so that can detect the velocity. Okay, and using the position sensor also you can just take derivative of that, you can obtain velocity, that we'll see. Okay, accelerometers are there, that is there in your mobile phones also, so we'll see that also. So we'll see a type of accelerometer which is a MEMS sensor, and maybe using a force sensor, that also will be covering in this module, that can be converted to an accelerometer also. Okay, so force sensor, strain gauge in particular will be covering. Optical and piezoelectric is also there. Okay, so these are mostly used in industry. Apart from this, definitely switches are there. That is very common. Even switches like keyboard, your desktop keyboard is also a sensor. It can detect what you are pressing. Okay, so that also is a sensor. So there are various kinds of it. Double pole, double throw, single pole, double throw, single pole, single throw, or keypad, your encoders, all these are just switches. So we won't be covering switches as such. So we'll be covering till 5. Okay, and others are special sensors which are also there in the industry, but not specifically it is always there in the robot. So we are skipping those at least for this model. So they are pressure sensor of various kinds which are mentioned here. Flow sensor, liquid level sensor, temperature sensor, light sensor, and special sensors like machine vision, tactile, slip or touch sensors. So these are various types of sensors. Okay. So yes, let us start with position sensor. Before we actually start, let me just expose you to your own mobile device. Even I have this now. So just see this one. Okay, what it is showing. This is the number of devices which are there in my tab, at least that one which I am using. So you can download a similar one for your mobile phone also, and you will be surprised to see these kind of data. So it has so many sensors. I am sure you are aware of this, but yes, at least a few of them I will demonstrate here. So this is accelerometer which is there. So if I move it in one axis, you can see this. It is giving you some kind of acceleration in one direction. If I am moving in some other direction, it shows something else. If I move along this, yes, it gives me some other plot. So all the 3 axes it has accelerometer sensor. So yes, it gives me. So linear acceleration is also measured. So if I keep it flat, you see one of them is going to 0. So that is the Z1. Okay, so that is a linear, that is the acceleration actually, not the G value. Okay, so it is just the static acceleration. It is just the acceleration of your device. Okay, so if I am not moving continuously, it won't go. But yes, at least you can feel the difference. Something is there if I am shaking it. Okay, so magnetic field sensor is there, gyroscope is there, which can measure the angular velocity, gravity is there. So at least you can see it is going up to 9.8, 9.9 along z-axis if it is kept flat. If I make it like this, okay, so you see it is becoming y-axis 9.8. If I keep it like this, it becomes z-axis almost 9.8. So this is the gravity sensor. So it has magnetometer, it has gyroscope, it has many other sensors also. You see there are many. So you see you have already preloaded with a good amount of sensors in your devices, right? My touchpad is a device which is a sensor again, that is a capacitive sensor. My camera, that is also a sensor, that is a vision sensor. So you see you are flooded with sensors nowadays. Just keep your eyes open, you will find them. Okay, so let us move ahead with position sensor now. Okay, that is optical encoder. Incremental we'll start with, we'll go to absolute also. So yes, how does it work? So this is very simple. You see there is a disk. There is a disk over here with windows. Okay, you have a disk with window. Okay, those are holes in this disk. Okay, so if you have a LED light from one of the direction, okay, and you have a photo sensor over here, so this light will pass through whenever it encounters the window. Otherwise it is obstructed by the walls which are here. Okay, so the photo cell which is there will give you a high signal when it sees a window, and when it is obstructed it will go to 0. When it is obstructed it will go to 0. So got it? So what we are going to do here, so effectively if the wheel keeps on rotating continuously, what you will see? You will see a square wave kind of thing. Okay, not necessarily, because light is not 100% or 0%. Sometimes it is partially opened window. In that case you won't see 100% high, you may see a little bit less of a high. So you can set a threshold. So that thresholding circuit is here, which is known as squaring circuit. that basically converts it to a complete square signal. So it is nothing but a comparator, beyond which it will show it as 1, below which it will show it as 0. So it will give you a square wave. Okay, so at least now you see, so if this wheel keeps on rotating, what you will get is a square wave. Okay, okay. So now, is it sufficient to measure the angle? Yes, it is sufficient. If you know the slot, what is the width of my slot and total number of slots, so if you just count the number of slots, you can understand, yes, my wheel has rotated by this much of angle. Let us say there is every slot is of 1 degree and 1 degree blank. So overall you can have as much as total 360 divided by 2, that is 180 independent slots will be there. So if you see 180 counts of high signal, you understand my wheel has rotated by 1 full revolution. Okay, so that is okay, but whether it rotates clockwise or anti-clockwise, it will give you same kind of square wave. So how will you know that? In order to do that, there is a trick. You have 2 different LEDs and 2 different sensors. Okay, so if one of them is going high, other one goes high after a moment if this wheel is moving, otherwise it will remain there. Got it? So you will get a shifted waveform over here. So there is a shift in between. Okay, so if this appears first and this appears second, it rotates along clockwise direction. So if it is anti-clockwise direction, you will see a reverse pattern. Okay, and that is how you can measure whether it is rotating clockwise or it is rotating anti-clockwise. Got it? And just by measuring number of counts, you can get the angle. So you now get the complete sense of it. But yes, it is not absolute. Okay, if I say how much it has turned from a reference line, so you cannot say, because you might have already rotated and then switched on your circuit. So it just measures number of counts of slots from the point where it has started counting. Okay, so it is a relative position. So you can keep on adding if it moves clockwise, and you keep on subtracting if it moves counterclockwise. Got it? So that is how it can measure. So but yes, it is a relative sensor. That is the reason it is known as incremental sensor. Got it? So yes, now there are many other ways of getting more resolution and other stuff. So maybe you can count this rising edge, falling edge, and again rising edge and falling edge. So one complete window to window transform, you will get at least 4 counts. So you can increase the just one high for one angle turn, one slot turn is converted to at least 4 different kind of signal, which you can use it to further resolve it to 4 independent instances. Okay, so just one slot is further subdivided. So anyway, that is a bit not much complex though, but yes, this is the way you can even have more resolution of a just out of one window count. Okay, so yes, what all things that it is giving is, it is giving a sense of relative change in position of each joint and rotation angle, and this slots can be also made on a linear rail kind of thing. Okay, so you may have slots like this, slots, and you have a LED, you have a sensor over here, photocell, and you can count the number of slots if something is moving even in a linear way. Okay, so that also is possible. So yes, and then what all things that you got out of it is a count. Count will give you, it has direct relation to the angle or displacement. Velocity is nothing but number of counts appearing per unit time is its velocity. And direction, using the 2 inputs A and B, you can get the direction. Sometimes you have an additional slot of very small width that is known as an index width. That is just one signal that you are going to get after every one complete revolution. So it will, if you count this one, it will directly give you number of complete revolutions per second. Okay, you can directly get that. So this will also save, instead of counting, let's say 360 high signal for one complete revolution. So for every 5 revolution, 360 into 5 number of counts are going to appear. Okay, so to avoid that huge number in your variables, you can just keep a track of your index. So if you got one index plus, let's say, 5 counts, so you can have counts like that. Okay, one index means one complete index to index is 360 counts. So just keep the track of index count and then number of independent counts that you are getting. So this is the way it can save your space, variable space also. And it is a non-contact type of sensor. So it is an optical, it is an optical sensor. It can be magnetic types also. So what is magnetic type? Basically, you must have seen older days, you had a magnetic cassette. Okay, so it has data written at every location. So you have a pickup head that can read those data. So you can have 1, 2, 3, 4, 5, 6 like that. You can have n number of, so it can be very, very dense. So those kind of sensors are also there. That is also a non-contact magnetic tape type. Okay, so yes, and multiple turns with gearing can improve the resolution. Let's say your motor has rotated by just 1 turn, but you have a gear attachment that can rotate this disc by, let's say, 5 turns. So 360 per turn into 360 into 5 total counts you will get out of just 1 turn of that motor. So your motor has a gearbox and then you have encoder. So gearbox maybe 100 times, maybe any times. So that is additional resolution you can get. Okay. So optical encoders can be a rotary type, it can be linear type. So one is close-up view of real picture is shown here when this is a disc, and you can see clearly you have slots here. Okay, you have slots here, and these are the circuitry to do the pickup operation. So one side of it has a LED, other side you have a photocell. Okay, and similar is one of them. This is for linear displacement sensor. So it is nothing but like a tape which I am holding in hand. Okay, so I don't know if you can see it very clearly. So I cannot see it, it just appears gray to me. I cannot count the lines, they are so fine, so fine. So this type of tapes are there. Okay, so that tape it can measure also. Okay, so this is a type of counter for linear motion. Okay, so there are many advanced types. So one of them, it looks like this. I am sure quite a lot of you have seen this earlier also. Okay, so if you see this, it looks like this. Okay, it has a counter rotor which is here that effectively rotates the inside wheel that has slots. Okay, that's all. It looks like this. It has a flange and it can be coupled with any other link which goes next to it, and it has how many wires? You just count this. So it is 4 number of wires. So one goes to VCC, that is the supply, other one to the ground. So those are the supply for a LED, and then you have 2 output signal phase A and phase B. There are many advanced type of such sensors also which does all these counting thing inside the sensor only. So one similar one I have in my hand. It's a very expensive and quite high number of count. It can get something around 10,000 counts it can give. So yes, this is from SICK. It's a company. Okay, so you still again have this type of rotor. Inside there is a disc, and you see there are many wires here. So one of them is to power the device, other one gives you a ready-made signal at the end. So it looks like this. So at the end I can directly get something which is like Ethernet cable. So you see it is very much like Ethernet cable. So it gives me an output directly in the form of Ethernet signal. So you can interface directly your advanced devices like PC directly without having any type of acquisition system. Got it? So that is a very advanced type of encoders. Okay, so yes, this is a incremental sensor, and now you see how a absolute position sensor can be made, which can store the value, at least the starting value. So if it moves even when the system is shut down, so when it starts, it can directly get where I am. Initially, if you remember your printer, whenever you start your printer, your head goes to the home position. Why? So that is an incremental encoder probably which is there. The strip which I showed you, it is a pull out from such printer only. So yes, it is an incremental sensor. So your cartridge goes to the home position. As soon as it reaches home, there is a limit switch which says yes, now you have to start counting. Wherever it is, bring it, keep moving it until it comes to the home position and triggers that 0 limit switch. When that limit switch is on, start counting. When it moves here, keep on adding. When it moves back, keep on subtracting, and that is how it keeps the track of your head position. Got it? So yes, that is incremental, but still by homing operation you can maintain that. But if you have an absolute position sensor, you don't require that. Okay. So one of them is reflected binary code or gray code sensor. It is named after Frank Gay, a researcher at Bell Labs. Okay. It is absolute position, used for absolute position sensing. Two successive values differ only by one binary digit. So two successive values should differ only by, let us say I have coded this disk by binary digit of 3 bits. So what do you see? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so I think I am right, I don't know. 0, 0, 0, 0, yes. 1, 1, okay, I have missed one. That is 1, 0, 0 here. Then this. So 1, 2, 3, 4, 5, 6, 7, 8. Yes. So 2 to the power 3, that is 8 independent values you can store. So yes, what you see here is at a particular location, you may, if you code your disk like this, so from here to here, just one bit is changing. You see, just one bit is changing. That is fine. But from here to here, even this is changing and this is changing. So two wires are changing at a time. Okay, two wires can change at a time. Sometimes one wire is changing, one wire is just changing. Okay, other one, you have two wire which is changing. What do I mean? I will tell you. Let us say this is an arrangement. Okay, your disk is coded like this. You have optical pickups which are here. Okay, so that just sees the reflected light. If it is black, there won't be any reflected light. If it is white, you will see a reflected light. Okay, so these 4 pickups will pick up what is written on this disk in this 4 bits. 1, 2, 3 and 4 bits. Okay, so all the 4 bits it will turn on 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1 like that. So it will directly give you the values which are stored there by just checking the values in these wires. So that is what I am talking about. So you see, if 2 wires are changing and one of the wire is faulty, so you won't come to know whether it is just this change is because of rotation or because of some faulty wire. Got it? So in order to avoid that Gray has come up with a new idea that you shuffle this in such a way, this binary coded decimal, in such a way that at a time only one of the bit will change. Okay, at a time only one of the bit will change. So if at all by any cause of fault, if you see 2 wires are changing, that means your device is faulty. It has fault tracing capability immediately within the device itself. Got it? So you should not see 2 wires getting changed at a time. If it is changing, your device is faulty. Okay, so that is the beauty of having gray code instead of binary code. Okay, so this is this less switching improves the reliability. So that is the beauty of having gray code. So see how it is generated. So let me draw it once again here. So how you can make, let us say, a 3-bit of gray code without actually doing some sort of shuffle operation. So 3-bit of binary you can quickly make. Okay, so let us say binary is 0, 1. So next time when you do, you have to do 0, 1 and 1, 0. Okay, so this is just, and you just have to mirror about this, and then you add 0, 0 here and then 1, 1 here. So this gives you a gray code of 2 bits. Okay, now how to generate 3-bit gray code? How to generate 3-bit gray code? So you just copy this. You just copy this. So 0, 0, 0, 1, 1, 1, 1, 0. Now I'll mirror it about this line. So I'll write 1, 0, 1, 1, 0, 1, 0, 0. Got it? So it quickly comes from here. Now I'll add 0 like this and 1s for all of them. So this gave me a gray code of 3-bit. So that is the way it is generated. There are other ways of generating it electronically also, or by programming you can do it. So this is how I have generated this 3-bit gray code. So, and you see in any of the 2 consecutive data, only 1 bit is changing. So this is changing from here to here. From next one you see only this is changing. Next one you see this is changing. Okay, and then you see this is changing, this is changing, this one is changing, and finally this is changing. So you see only 1 bit has changed. So that is how it improves the reliability. Okay, other ways of generating is electronically using NOR gate is something like this. You simply input the binary code here 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, and like that. So you can just keep on feeding here and you will get gray codes here in this 4 wire, right? So this is just a operation which is happening here, which is explained, and this is a disk which is something around 4096 data which is saved over here. So that is how you can have a disk with so many values, but the things are very, very complex here. You have very good number of wires that has to pick up this signal. You have so many LEDs that again makes things little unreliable. So at least for this many counts it is quite good enough. So that is your optical sensor, non-contact sensor, and absolute also. Okay, so change in data per unit time is the velocity. Position you are directly getting, each position is a unique value. If you get that value, that means you are in that position. Position and direction, if that value is going right hand side or left hand side, you can directly detect them. So direction, speed, position, everything is obtainable using this. Okay, so this is there, and then this is a linear pickup arrangement which is there, you see. And you, if you know yet, I don't know, your mouse also has got an optical sensor here. Optical sensor here. So if I do some cursor movement, that is because of this sensor. So that is an optical sensor. Okay, so that has a similar arrangement. It has a light that is thrown out, and it is thrown on the table on which you are swiping your mouse, and then reflected picture is taken, and change in that image is analyzed to find out which direction you are moving. So that is an optical sensor, non-contact, and it detects displacement, I tell you. So that is a very good displacement sensor that you can get something from off the shelf of your mouse. You can just pull it. Okay, so this is linear encoded strip, the one that I showed you out of my printer. Magnetic pickups are very, very similar, but instead it has a ferromagnetic tape which can store data. This is magnetic pickup, and linear pickups are like this. So yes, that is what is magnetic absolute strips. So these are some of the application when you see a flywheel is having a kind of reflection mirror placed here. So every time that mirror comes in front of that LED and photocell, it will count it as 1. Okay, so every time it goes there, it will simply say number of revolutions per minute or whatever is encoded there. Okay, CNC lathe lead screw. So this is the encoder which is fitted. So as many number of count this shaft will rotate, that is the tool post will move along this path. Got it? So that tool is going to move like this. So by measuring precisely this angle here, you can easily calculate how much turn my lead screw has rotated and what is the displacement of my tool post. So this is how it is used in CNC lathe or those kind of machine. Your Logitech or any manufacturer, gaming controller, you see you have a joystick. How does it come to know what is my rotation? Maybe you have a steering wheel that is used to play various games. Okay, so that is steering the wheel rotation, how much you have turned, is also sensed using this kind of arrangement. Okay, so you can clearly see the slots which are here. There is a photocell and pickup arrangement which is here. Okay, and this is nothing but a motor. Aft side of the motor is fitted with the encoder here, the one which I showed you, very much similar to this one. Okay, it is fitted here. Okay, so that will give you directly the speed of your motor also, and sometimes position. If it is position controlled, you are interested, you can get that. And what is this? This is a cam crank electronic governor system. Electronic governor basically is used in alternators or generators which generate electricity for you, because you have to maintain constant speed of your shaft to maintain, let's say, 50 hertz frequency of your output. Okay, so let's say you have to maintain, let's say, 720 RPM for that. So that is measured continuously, and it is velocity is fed back and maintained using a type of controller using electronic governor system. So electronic governor continuously takes feedback of speed and maintains that speed using fuel rack system. Okay, so that is what is there in electronic governor. And these are various types of sensors that I have showed you. Yes, that's all. Thanks a lot for this lecture, and next class I will be discussing more upon absolute sensor, that is potentiometer is there. So I will be discussing on potentiometer, magnetic sensors, and special kind of magnetic sensor, that is Hall effect sensor. I will be discussing in next class. That's all. Thanks a lot.